Welcome to Surge's Happy Learning. Let us continue discussion of scalar quantity, and I'm sure that after watching this video you will have clearly understood the meaning of the scalar quantity. Therefore, I suggest you to watch this video till the end. As discussed in the earlier video, scalar quantity is a type of physical quantity. Its another class is vector quantity. But in this video, we will discuss only the scalar quantities. A quantity which is completely described or fully explained by its magnitude and unit is known as scalar quantity. Magnitude of quantity is nothing but the numerical value. It is nothing but size of a quantity or even amount of that quantity. In the scalar, we need only magnitude along with its unit. There are few examples considered here of a scalar quantity as mass, length, that is the distance covered, time, temperature, volume, speed, and work done. Let us quickly go through one by one these physical scalar quantities. First of all, mass. If we see the images, in the first image, we come across weighing balance. Earlier, to measure the mass, these types of weighing balances were used. Nowadays, digital weighing balance is used for measurement of mass. Then we see a disc attached to the spring. That disc has a mass, and because of that mass, the spring is elongated when mass goes down and compressed when mass is released or comes up. We have considered here three examples as see the my mass is 75 kg. That is I have denoted as m1 equal to 75 kg. Here 75 is the magnitude and kg, that is kilogram, is the unit. Then another example as m2 equal to 100 gram. 100 is a magnitude, numerical value, and gram is the corresponding unit. Whereas m3 equal to 125 milligram. 125, the numerical value, that is the magnitude of the mass, and milligram is the unit of mass. Then the second scalar quantity considered is length. That is nothing but the distance covered. In the GIF image, we find or rather we see a boy walking. While he walks, he covers some distance. He goes through length of a distance. Then, how much distance that boy has covered can be measured by using measuring tapes. Like today, in the morning walk, I walked for 10 kilometers, and here it is denoted as L1. 10 is the magnitude, kilometer is the distance. Whereas another examples like L2 equal to 100 meter and L3 equal to 1000 millimeter. 1000 millimeter, here 1000 is a magnitude and millimeter is the unit of this length L3 or the distance measured. For measuring distance, measuring tapes can be used. Then time as a scalar quantity here. To measure the time, we use wristwatch or the wall clock also. Time can be measured with the help of digital clock. Here in the second image, we see the time indicated is 5:59 p.m. and there is a timer also. It's of 1 minute. Here, this timer now counting in the upward fashion and incrementing 1 second uh, in earlier value. We consider time t1 as an example as equal to 1 hour, t2 equal to 45 minutes, and t3 equal to 30 seconds. Here 30 is a magnitude and seconds is the unit. Then temperature as a scalar quantity. In the first GIF, we see that a man is suffering from the cold and he is rather waiting for coffee. The temperature may be very low, like T3 equal to minus 25 degree Celsius. The temperature can be measured with the help of thermometers. Today's high temperature at my place, T1 equal to 36 degrees Celsius and expected low temperature is 25 degrees Celsius, where 25 is a magnitude and degree Celsius is the unit. Then volume as a scalar quantity. V1 is equal to 10 meter cube. That can be a volume of a room where 10 is the magnitude and meter cube is the unit. V2 as equal to 100 meter cube and V3 equal to 1.5 liter. In the second image, we see uh, drinking water bottles. Those bottles are of volume 1 liter, 1.5 liter, or even uh, 2 liter. Then we can see how the gas which is kept in this particular IC engine is compressed. The gas particles are pushed together when compression is done, and those gas particles move away from each other uh, during exhaust operation. Then the speed. We see the bullet train, which may run at the speed of 340 kilometer per hour. Whereas in the second image, we see the speedometer, which indicates the speed of a bike or speed of a car. Here, the indication is in terms of kilometer per hour as well as in terms of mile per hour. Here now, speedometer is indicating about 130 kilometer per hour and round about 77 mile per hour as a speed of a moving object. In the GIF, we see a biker driving bike at a very high speed on a curved path. The speed U2 can be 80 km per hour. Here 80 is the magnitude and kilometer per hour is the unit, and U3 as 20 kilometer per seconds. Here 20 is the magnitude and meter per second is the unit. 20 meter per second means this particular object or even bike moves 20 meter in 1 second. Then the work done as a scalar quantity. In the first image, we see that two girls and a boy to the left are actually pulling the rope in opposite direction. If the force applied by two girls and a boy to the left are equal, then they will not be able to move. But if those two girls apply more force towards right, rather pulling force towards right, than the boy who is pulling the rope to the left, then the rope will move towards right and that boy will be displaced towards right. Then in the second image, we find a girl using trolley to move the object. Now she is pushing the trolley on which the objects are kept. Means applying force on the trolley so that objects are moved. And there are two magnets. Opposite poles of magnets, if are brought close to each other as south pole and north pole, then a force of attraction is produced in the region. Then magnets move towards each other. In all three examples, we have seen that applied or produced force does the displacement of the object. Work done is nothing but force which is resulting in the displacement or which is causing the displacement. Hence, work done as force into or force multiplied by displacement. Here the example says W1 equal to 100 joule, where 100 is the magnitude, joule is the unit. Work done W2 equal to 25 joule and W3 equal to 4.7 joule. Then scalar quantities can be uh, manipulated by using basic simple rules or simple arithmetic rules. Here scalar quantities are added like regular numbers. Here mass M1 is 10 kg and mass M2 is 5 kg added and resulted in 15 kg total mass M. Whereas 1 kg mass is added to 100 gram. That has resulted in the addition of 1 kg as 1000 gram plus 100 gram results in 1100 gram. That is nothing but 1.1 kg. Here, if units are different, then we have to convert particular magnitude in a common uh, type of units. Either we can convert gram into kg or kg into gram and then do addition and other type of operations. Time also can be added like t equal to 2 hour plus 3 hour that has resulted in 5 hour. Then subtraction is also like regular numbers as 10 kg minus 5 kg results in a 5 kg mass. 1 kg minus 100 gram results in 900 gram, that is nothing but 0.9 kg. And in case of time, 3 hour minus 2 hour results in 1 hour. Then multiplication of a scalar quantity as speed equal to 20 meter per second, and we have considered time as 10 seconds. Then if speed and time are multiplied as 20 meter per second into 10 seconds, then second get cancelled and we get 200 meter, a new quantity, that is distance, which is again a scalar quantity. Then we have division of a scalar quantity. Again, we considered mass as 10 kg, volume equal to 1 meter cube. Then if we divide mass by volume, then it results in 10 kg divided by 1 meter cube as equal to 10 kg meter cube. And this is new physical quantity. It's a scalar quantity, density. Then after this much discussion, uh, you are expected to answer this question. You can write answer of this question in the comment box. The multiple choice question is scalar quantity has only, okay, you have to fill in the blanks as option A direction, option B magnitude, C as magnitude and direction, and option D none. This is all about scalar quantity. I hope you may have understood everything regarding the scalar quantity as which are the basic examples of it and what is the basic requirement of scalar quantity as well as how scalar quantities are manipulated, means various operations are performed on the scalar quantities. You are expected to write answer of the asked question, and even you have any doubt, you can ask those doubts or the queries in the comment box. I hope you will like, share the video and subscribe Sorge's Happy Learning. Thank you so much from the Sorge's Happy Learning.